Okay, so the first thing we need to be able to do is read the notation. So the first question asks us to reflect segment CD across segment AB. To do the reflection, we need to remember that the line of reflection is the perpendicular bisector of the segment connecting image to pre-image. So we need to make some perpendiculars from C and D. To make those perpendiculars, we want to get out our compass, and I'm going to draw an arc that starts at C and intersects my line of reflection twice. And then our next step, and there are a couple ways to do this, but what I like to do is I like to measure from those intersections to point C. And then I'm going to make an arc from the left end point of my line and also from the right. So now, where these points meet, right here, that point is equidistant from the two endpoints of my segment as C is from those two endpoints, which means it is the same distance from my line of reflection, which means it's the exact location of C prime. If I had not set the compass to this radius, I would have had to draw the full perpendicular like this. Oops. I would have had to draw the full perpendicular. Let's try that again. And then I would have had to measure how far is C on that perpendicular, and then I would have had to copy to get that length for C prime. So it's just a little bit of a shortcut. So we're going to do the same thing for D. I'm going to change colors because I'm using a new radius. And I'm going to draw an arc that hits my line twice. I'm going to measure from one intersection to D. Conveniently the radius I already used. And we're going to draw an arc from one endpoint and also from the other, and where they meet must be D prime. Now we are supposed to draw the segment, and so I finish by connecting C prime to D prime, and I'm done. The next construction, actually let's move over to 14 because it is another line of reflection construction. This time we're finding the line of reflection, and I actually think this is a little easier than reflecting. To find the line of reflection, we keep in mind that it is the perpendicular bisector of a segment connecting pre-image to image. So we start by connecting pre-image and image, and we're going to bisect this segment, and we can set our compass to the full length. As long as it's more than halfway, you'd be okay, but I'll go with the full length for this one. We draw an arc from B and also from B prime. And when we connect those, that perpendicular bisector is my line of reflection. And I'm going to include arrows because it is technically a line of reflection. And that's it, we're done. And I chose the B's. You could have done C to C prime, you could have done D to D prime. It doesn't matter as long as they are corresponding points. Next, a translation question. And this is where we want to translate segment AB according to vector CD. So every point has to move that far. And this is the one where the idea behind this construction is really to kind of create a parallelogram that looks like this, and then a parallelogram that looks like this. That's what we're really doing. That's why this construction is going to work. So the first thing I want to do is measure from the distance from C to A. And I'm going to draw an arc to prove that I measured that length. Now the length from C to A should match the length from D to A prime. So I know that A prime belongs somewhere on this pink arc. Next, we're going to measure the length of our vector. And our vector goes from C to D. I am going to put a little arrow here to prove that I measured it. And so my point A has to travel that same distance. And where those two intersect is where A prime must be. Now we're going to do the same thing from point B. I'm going to measure from C to B or B to C, same thing. I'm going to draw an arc to prove I actually measured it. And we have to go the same distance from point D. Now, and I already measured this once, but I'm going to have to reset my compass, I guess, to the length of CD. And point B has to travel that same distance. So B prime is going to be right here. And to complete the construction, we connect A prime and B prime. So my vector has gone to the right and up a little bit, or my segment, just like the vector. Next, here we have to identify a vector of translation. This one, it doesn't say construct because a compass isn't even really necessary. To do the vector, we just have to connect any point in the pre-image to its corresponding point in the image. And we're done. I chose the B's, and that was really because I didn't want to cut through the figure. But I could have connected the A's, I could have connected the D's, it doesn't make a difference, but that's it. Number 13. Now this is the one that you may or may not have to do, depending on which class you're in. So we're going to call this like a bonus construction at this point. But this is where we're going to rotate segment AB around point C. And what that means is point A needs to rotate and point B needs to rotate. And they're both going to rotate according to this angle. So first, to rotate point A, my first step is to connect point A to the center of rotation. My next step is to draw a nice big arc that goes through A. And what this arc is representing really is this is the path that A travels on as it rotates. So that's our path. If it kept going, A would continue to go in this direction. We don't need the arrow, but it's just so you can see what's happening. That's where A is moving. Now we need to figure out how far is it moving. And so that's where we need to copy this angle. Now to keep this to be a little bit less work, something that I like to do is use this radius that already exists. So I'm going to have to extend my angle a little bit. And that pink arc that I drew already, I'm going to draw that same pink arc right here. So imagine that that's the path of A. We need to now figure out how far did A move. And so to figure that out, we measure the length. So this is the length of A along that purple arc, that pink arc. So we're going to come over to our arc and do the same thing. Here's my distance that it's traveled, and therefore this is where A prime is ending up. Now I'm going to do the same thing for point B. I start by connecting it to the center of rotation. Next, I'm going to measure from the center of rotation to point B. And I'm going to draw the path that B takes as it rotates around point C. And I'm going to do that same thing on my angle. Oops. Which coincidentally almost goes right through F. So that's the path that it's taking. Now we have to figure out how long is it on that path. So we're going to measure that length. And we're going to measure over here. This is how far it has to travel. And where they meet is B prime. And because it did ask us to translate the segment AB, we need to connect them, and we get segment A prime B prime. And that's what it looks like after it rotates around point C. Our last construction is rotating, given the rotation around point O of 75 degrees, find and label point O. So really, they're basically, when they write this, it's a fancy way of saying find the center of rotation. And to get the center of rotation, we start by connecting any points in the pre-image to its corresponding point in the image. And then we're going to do a perpendicular bisector of that segment. Whoops. I'm going to stick to purple for this one. And this is where, because it can get a little bit messy, I do recommend using C prime as your radius and drawing the full arc. But when we sketch this in, and I'll bold my line a little bit, we get a perpendicular bisector of C prime. And we have to do the same thing for another set of points in this image. So I guess I'll connect A and A prime. And I'm going to bisect those. I'm going to set my compass to equal AA prime. Draw an arc from A prime. Also draw an arc from A. And for me, using color here makes it a lot easier to see. So I would throw your colored pencils into your compass if you can. So I'm going to connect one orange intersection to the other orange intersection to get my second perpendicular bisector. And where those perpendicular bisectors meet, that is my center of rotation. And now the step you don't want to forget is it does say construct and label, so don't forget to label that as point O.